Today, I am Andrew Medina from 3MEA. I will give you another video procedure on how I came up with my answers for the degree of mobility assignment for Machine Elements Lab. So for our first mechanism, we're given this machine and we are to calculate the degree of freedom of the machine. And actually, we're already given the links and the pairs in this machine. But we have to determine which symbol represents which pairs and which symbol represents the links. So just looking at this mechanism and remembering our lesson from the previous assignment, we could already remember that the pairs represents more like the joints of the mechanism, and the links are the ones that are able to connect different parts of the mechanism to one another. So looking at this equation, this mechanism, we could see that the letters actually correspond to the joints or the pairs of this mechanism. And looking at it further, we could see that the joints or the pairs are only connected at a specific point. Therefore, all the joints present in all the letters are all lower pairs. Therefore, there are no higher pairs in this equation. Okay? So after that, it makes more sense looking at the numbers representing the links of the equation, because we can already see that number 1 is the frame of the equation, frame of the mechanism, and the corresponding numbers would be the different links, different binary links, binary link with point of interest. Therefore, let's write the given. So let's write number of links. Now let's count the links. We have the frame 1, 2, 3, 4, 5, 6, 7. There's only 7 links in this mechanism. Next, we have to count the number of lower pairs. Now remember earlier, we can see that there's no higher pairs, because higher pairs would be a pair or a joint that's connected along a surface or along a line. Okay, so we don't have anything that would be connected to that sort of mechanism. So all of these are singular revolute pairs. So remember that. Number of pairs, let's count. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 lower pairs, which are all revolute pairs. Finally, number of higher pairs, we have 0. Now let's make use of Grubler's equation to get the degree of freedom of this mechanism. So the degree of freedom would be equal to 3 times the number of links minus 1 minus 2 multiplied to the number of lower pairs represented by J minus the number of higher pairs represented by H. Now plugging in our previous values into Grubler's equation, we have 3 times 7 minus 1 minus 2 multiplied by 8 minus 0. Now inputting these into our calculator, (7 minus 1 multiplied by 8), we have a final degree of freedom of 2. Therefore, our degree of freedom is equal to the value of 2. So for the second question, we have this mechanism, and again, looking at the mechanism, we could see that the joints or the pairs are signified by letters, and that the numbers would correspond to the links of the mechanism. This would be binary link, link with binary link with point of interest. This would be our frame. So let's count this. Number of links would be our frame 1, 2, 3, 4, and 5. So we have 5 number of links. Now let us see if we have any higher pairs in this mechanism. Now upon further inspection, we could see that the joints only connect to specific points. Again, we don't have any line or surface that connects to another surface. It only connects on a specific joint. Therefore, all of these pairs are lower pairs, and all of these pairs are revolute pairs. Yet again, let's count the number of pairs. We have 1, 2, 3, 4, 5, and 6. So the number of lower pairs would be 6, and the number of higher pairs again would be 0. Now, let's use this Grubler's equation to find the degree of freedom of our mechanism. Plugging in our values, we have 3 multiplied by 5 minus 1 minus 2 multiplied by 6 minus 0. And then putting this into our calculator, five minus 1, and we have 6 multiplied by 6. So finally, we have a degree of freedom of 0. Okay, so this is our question 3. And again, we are given a mechanism and tasked to find the degree of freedom of the given mechanism. Now, before moving on to the following questions, the next questions, I want to make something clear. I actually made a mistake before in saying that a lower pair would be a joint that constrains contact in a certain point between two surfaces, two bodies. And earlier I also said that a higher pair would be a joint that constrains contact between a surface, two surfaces of different bodies. But I want to make it clear that actually a lower pair is a joint that constrains contact between surfaces of two bodies, and that a higher pair is a joint or a pair which constrains contact in a certain point or surface between those two bodies. So I seem to have mixed them up, and I'm sorry. Those are actually 2 out of 3 of the classifications of kinematic pairs that we'll be using today. So now, determining our number of links, number of lower pairs, and number of higher pairs, we can actually see that question 3 is a very special question because there happens to be a hidden pair within this mechanism that's not labeled, and this would be the higher pair present between the two surfaces, present in a line between these two surfaces of these two bodies, and we'll label this higher pair as higher pair E. Higher pair D, I'm sorry. Let me correct that. So now let us count our links. We can see that the numbers correspond to the links and that the letters correspond to the joints or the pairs in this mechanism. So to count our number of links, we actually want to correct an error or a typo in this question, in that in the number of links, there are only 4. So this would be link 3, and this would be link 5. Link 4, I'm sorry. So counting the number of links, we have 4 links. And counting the number of lower pairs, we have 3. being that two of these lower pairs are revolute pairs, and that the third pair would be a prismatic pair. So we have 3 lower pairs. Finally, counting the number of higher pairs, we have a singular higher pair which we label D, 1. Now, using these values in Grubler's equation to find the degree of freedom, we're going to plug this in. 3 multiplied by 4 minus 1 minus 2 multiplied by 3 minus 1. Now, putting this in our calculator, minus 1 higher pair. So that would be 4 minus 1. That would be multiplied by 3. So we have a final degree of freedom of 2 for this mechanism. So for our fourth question, we are actually given a kinematic diagram of this mechanism, and we are still to determine the degree of freedom of this mechanism. So looking at this mechanism again, at this kinematic diagram again, we could see that the letters would correspond to pairs or joints in the mechanism, and that the numbers would correspond to the links between these joints. Our first is the frame. And let us count the number of joints. Let us see if there's another error in our question. We have 1, 2, 3, 4, 5, 6, 7, and 8. And this is just one single link. This is a binary link with a point of interest. Okay, so this is correct. We have 8 number of links. Now we are to determine if there is a higher pair or lower pairs in this mechanism. And looking at it again, let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all similar pairs, and that pair being revolute pair. And let us remember that revolute pairs are all lower pairs. So let us count our number of lower pairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 lower pairs and 0 higher pairs. Now, putting these values into Grubler's equation, we have 3 multiplied by 8 minus 1 minus 2 multiplied by 9 minus 0. Now, using our calculator, zero higher pairs, 8 minus 1, and 9 lower pairs. So, as we can see, the degree of freedom of this mechanism, mechanism 4, is a value of 3. For our fifth question, we are given this kinematic diagram, and we are tasked to find the degree of freedom of this mechanism. And let us count our number of links, or rather find which symbol corresponds to the links, and which symbol corresponds to the pairs. Again, looking at this mechanism, we can see that the number of links, or the links in this mechanism, are corresponding to numbers. Okay, so this is a link, this is a link, this is a link. These are binary links with this as the frame. So let us count so we can see if there's an error. We have 1, 2, 3, 4, 5, 6, 7, and 8 links. Okay, so this is correct. These are all binary links. These are all singular links, so these are just binary links with a point of interest. So we can count that as one link each. So the number of links are 8. Now let us look if there is a higher pair present in this question. Now looking at this question, we can see that there's actually no higher pairs present in this kinematic expression, kinematic diagram. This is because no certain surface or no certain area, point of interest, connects between two surfaces of two bodies. So there's 0 higher pairs. Now looking at the number of lower pairs, we can see that it's signified by letters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. But wait, there seems to be a missing link which isn't labeled. That would be this pair right here, this joint. I meant to say pair, I'm sorry. These are where we were counting the pairs, number of lower pairs. There seems to be a pair that hasn't been labeled, so let us label that as J. So actually, in this mechanism, there are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 number of lower pairs. Now, plugging that into Grubler's equation, and 0. Now using our calculator, zero. This would be 8 minus 1, 8 number of links. This would be 2 times 10 number of lower pairs. And now, as you can see, as calculated, the degree of the freedom of this mechanism is a value of 1. Final question, we have our overhead loader. And if we remember the video that you gave to us in our assignment titled Degree of Mobility, we can remember that the overhead loader had a number of links of 12, and that the number of lower pairs, and that in an overhead loader there's actually 0 higher pairs according to the video, and that our number of links are 15. So putting this into Grubler's equation for degree of freedom, we have 3 multiplied by 12 minus 1 minus 2 multiplied by 15 minus 0. We have to remember that out of the 15 of these lower pairs, actually 3 of them are prismatic, and 12 of them, are all revolute. Now putting in these values into our calculator, minus 1, then we have 2 multiplied by 15. So our final degree of mobility or degree of freedom of this mechanism is a value of 3.